Good day, everyone. I welcome you to another episode of Organic Chemistry, and in this video, we'll be talking about the two major structures in organic chemistry. So generally, there are two major structures. If you want to draw any organic structure, you can either draw it in two formats, either using the Lewis structure or you use the KEKULE what? Structure. The Lewis structure is actually more complex than the KEKULE structure because it involves the valence electron, the writing out of the valence electron, which is the outermost electron, or writing out the outermost share electron. While for the KEKULE structure, doesn't involve all those long strains. So just for you to trace the covalent bond, then you put the covalent electron, the electron that are covalently bonded together, and just for you to put a bond there, a single bond. So that is just the difference between these two structures. So the first one we'll be looking at there is water molecule. We have ammonia molecule, we have ammonium ion molecule, we have carbon, phosphate, we have methane, we have methanol, and we have butene. So these are some of the molecules we'll be looking at in the course of this video. So before we look at this, I want to quickly show you the electronic configuration of chlorine. So chlorine has the atomic number of 17, and we believe that the first share is 2, second share is 8, next share is 8, and the next share is 18. The next one is 18, here is 32, and here is what? Is 32. So if you want to calculate the electronic configuration of chlorine now, it will be 2, 8, 7, because 2 plus 8 will give us 10, 10 plus 7 will give us what? 17. That means 7 here is valence electron of chlorine. I can easily say chlorine has 7 electrons in its outermost share, or chlorine has 7 electrons in its valence share. So if I want to draw this electronic configuration, I will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll draw another share again. 11, 12, 13, 14, 15, 16, 17. So we have 7 electrons here. So if I want to draw this structure, I will easily write chlorine 1, 2, 3, 4, 5, 6, 7. So this will not be, according to Lewis, this is how you will not draw the structure of chlorine. You just want to take the outermost share and then put it here. What about hydrogen? Hydrogen is 1, so the share will just be something like this. So hydrogen will not be H, 1 electron. Now, if I add these 2 electrons together, for hydrogen to be stable, hydrogen needs 1 more electron. For chlorine to be stable, chlorine needs 1 more electron. So what will happen is that they are going to share 1 electron. So it will, the electron will come here, this electron will come here. I mean sharing of electrons. They are going to bring the 2 electrons together. So we have hydrogen. Look at the hydrogen electron here. Then we have chlorine. 1, 2, 3, 4, 5, 6, 7. So the only bonding electron here, this is the only bonding electron. Why? This one here, this one here, these ones here, they are called non-bonding electron. Non-bonding what? Electron. And non-bonding electron, the other name for that is lone pair electron. So is that you call them non-bonding electron, or you call them what? Lone pair what? Electron. And this very one here is called a bonded pair what? Bonded pair electron. So if you want to draw this structure now, this is now the structure for what? For Lewis. If you want to draw the structure for KEKULE now, your mind should always go to the bonded pair. So, and according to KEKULE, 2 electrons, please take note, 2 electrons signify 1 bond. 2 electrons signify 1 bond. 4 electrons signify 2 bond. 6 electrons signify what? 3 bond. So as long as you are seeing 2 electrons here, how many bonds will you put there? 1. So your answer will be hydrogen bonded to what? Chlorine. You will not ignore this bonded pair. You can ignore these ones. It's not needed in KEKULE structure. So for KEKULE structure, this is your answer. But for Lewis structure, this will be your what? Your answer. So let me quickly show you the first one we have there, which is water. The first one we have there is water, and this is the formula for water, H2O. First of all, the first thing that will come to your mind is which of the elements will be a central element? Is it the hydrogen or the oxygen? Please, the answer will be the oxygen, because oxygen is 1 here, hydrogen is what? Is 2. So the number of the element that has lower value will always be the center, while the one that have a higher value will always be by the side. So you are going to have oxygen here, and oxygen has 6 valence electrons. So you have 1, 2, 3, 4, 5, 6. Oxygen has 6 valence electrons. Hydrogen has how many valence electrons? Hydrogen has just 1 valence electron. So hydrogen will come here, the one will be here, another hydrogen will come here, the one will be here. So the structure can look like this, or oxygen 1, 2, 3, 4, 5, 6, 5, 6. Hydrogen will be here, another hydrogen will be what? Be here. The structure will look like this. So if you want, this is even a standard structure. So if you want to draw this using KEKULE structure, it will not be oxygen bonded to a hydrogen bonded to what? A hydrogen. As simple as that. Because this double bond now will turn to a single bond. These 2 electrons will turn to what? A single bond. So this is how you draw it. Why the lone pair electron will be what? Will be ignored because they are not bonding. As if we want to draw something like this now, will not be oxygen, hydrogen, and here will be what? A hydrogen. So this is how you draw Lewis and KEKULE. So let's check for ammonia. Ammonia is NH3, and you just agree that as long as nitrogen is 1, hydrogen is 3, nitrogen will be the center element. And nitrogen has 5 electrons in the valence share. If you don't know how to check for the valence electron, first of all, here is group 1, group 2, group 1, group 2, group 3, group 4, group 5, group 6, group 7, and here is group 8. So here will be my hydrogen, here will be helium, the lithium, here will be our beryllium, boron, carbon, nitrogen, oxygen, fluorine. Here is my neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and what? And calcium. So the group number is equivalent to the what? The valence electron what? Let me write it the full. Is equal to the valence electron what? Number. So nitrogen belongs to group what in the periodic table? Nitrogen belongs to group 5. So how many valence electrons will it have? 5. Please, you write it like this. 1, 2, 3, 4. Let me put the 5th one here. 5. Then hydrogen here, how many electrons does it have? 3. How many electron is needed here to be stable? Is 8 electron. Please take note. So we have 5 here. For almost all the elements in the periodic table to be stable, we have 8 electrons. But for hydrogen and helium, they will then go to call the what? The duplet. Please take note. Now, if you have something like this, hydrogen, one of the hydrogen with one of the electron, because hydrogen has 1 electron, will come here. This is 1 electron. Another hydrogen will come here. This is hydrogen electron. Another hydrogen will do what? Come here. So this is called a lone pair electron because it is not taking part in the chemical reaction. Then your symbol will now be nitrogen. 2 electron equals to 1 bond. 2 electrons is equals to 1 bond. 2 electrons is equals to what? 1 bond. Then this will be our what? Our answer. Then the next one we have here is ammonium, which is NH4. NH what? 4. You have nitrogen, 1, 2, 3, 4, 5. Sorry, 5. Then how many hydrogen do you have here? Is 4. One hydrogen will come here with 1 electron. One hydrogen will come here with 1 electron. One hydrogen will come here with 1 electron. Then a hydrogen ion. Hydrogen ion means this hydrogen has no electron. It has given out, originally hydrogen have 1 electron. And if hydrogen give out one of the electron, it become what? No electron. It has no electron now. So that hydrogen will come here. So this will not be the structure. Most cases, it is best to put a plus here to show you that the molecule is positively charged because of the hydrogen. Ammonia naturally is neutral, but as long as the hydrogen plus is being added to it, the molecule itself become a positively charged what? Molecule. And if you want to draw this structure using KEKULE structure, you have nitrogen. 2 electrons here signify a single bond. 2 electrons here signify a single bond. 2 electrons here on that single bond, and here we got a single bond. Please don't forget to put the what? The charge. So this is what we call ammonium what? Ion. What about CO2? CO2 will be in this format. Carbon. Okay. CO2. Carbon will be at the center. Then oxygen. Let's draw the electron. Carbon belongs to group 4 in the periodic table, so carbon will be 1, 2, 3, and what? 4. For this carbon to be stable, it needs 4 electrons. So let me rearrange it for understanding. 1, 2. So the 4 electron is already there. So for carbon to be stable, carbon need what? 4 electron. And for oxygen to be stable, oxygen need two electron because oxygen belong to group 6. So for it to get to this place, we need two what? Electron. So one oxygen will be here, one oxygen will be here. And oxygen has 6 electrons already. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So if you look at this structure carefully, oxygen has 8 electrons, carbon has 8 electrons, and this last oxygen as well has what? 8 electrons. If you want to draw this is already a Lewis structure. So if you want to draw a KEKULE structure of this, you are going to have a carbon atom. 1, 2, 3, 4. Remember, 4 electrons signify a double bonded to oxygen. 4 electrons signify a double bonded to what? To oxygen. Why this lone pair electron here or this lone pair electron here will be ignored as long as you are dealing with what? With KEKULE structure. Like what I said earlier, if you are dealing with KEKULE structure, you don't need to put any lone pair electron here. You can ignore them. But as long as you are dealing with Lewis structure, all lone pair electron must be written. Then the next one we are going to write here is number 5, which is methane. Methane symbol is CH4. And if you want to draw carbon atom, like what I said earlier, carbon belongs to group 4 in the periodic table, so it will be 1, 2, 3, 4. And for carbon atom to be stable, you need 4 hydrogen. So one hydrogen will come here with 1 electron, another hydrogen will come here with 1 electron, another hydrogen will come here with 1 electron, and the last hydrogen will come here with 1 electron. Hydrogen obey the duplet rule. That means hydrogen need 2 electrons to be stable, and carbon need 8 electrons, which is the octet rule, to be stable. Let's count the electron that is here. We have 1, 2, 3, 4, 5, 6, 7, 8. So carbon is stable. And hydrogen has 2 electrons, 2 electrons, 2 electrons, 2 electrons, and hydrogen there is as well what? Stable. And this structure is a Lewis structure. If you want to draw the KEKULE structure, here will be a carbon atom, 2 electrons, 1 bond. 2 electrons, single bond to hydrogen, 2 electrons, single bond to hydrogen, 2 electrons, single bond to what? To hydrogen. So this is a Lewis structure for methane, and this is a KEKULE structure for what? For methane. Assuming you have a carbon 1, 2, 3, 4, 5, 6 bonded to another carbon, therefore it will be carbon atom 1, 2, 3, 4, 5, 6. C signify triple bond. So please, you can write 2 electrons signify a single bond, 4 electrons signify a double bond, and 6 electrons signify what? A triple bond. Then the next one I have here is methanol. The formula for methanol is carbon CH3OH. So if you have this as the formula, that means you have a carbon atom bonded to 1 hydrogen, 1 hydrogen, 1 hydrogen. Then here we have oxygen atom here. 1, 2, 3, 4, 5 plus this one 6. Then this oxygen atom is not stable. You need another hydrogen again to be stable. So you have something like this. So this is a stable structure. If you want to draw this now, you have a carbon atom bonded to a hydrogen, single bonded to another hydrogen, single bonded to another hydrogen, single bonded to oxygen, single bonded to what? Hydrogen. On a norm, I can try to put the 2 electrons here, but as long as I'm dealing with KEKULE structure, the 2 electrons can be what? Can be removed, as long as they are not taking part in the chemical reaction. Then the last one we're dealing with here is butyene. Butyene can be written as CH2 double bonded to CH2. So this simply means carbon atom 1, 2, 3, 4. 1, 2, 1, 2. Let me rearrange this, please. So what will happen is that a hydrogen will be bonded here, a hydrogen will be bonded here, a hydrogen will be bonded here, another hydrogen will be what? Will be bonded here. So at the end of the whole thing, the carbon atom, how many electrons do you have there? 1, 2, 3, 4. As long as you're having 4 electrons, it will be a what? Carbon double bonded to what? To carbon. Single bonded to hydrogen, single bonded to hydrogen, single bonded to hydrogen, and single bonded to what? To hydrogen. So this is the structure. Sorry, as long as I'm dealing with 2 carbon atoms, it's supposed to be 8. So this is a structure for what? For 18. So assuming we are dealing with 4 carbon atoms, then that's when I can use what? Both 2 in. So this is the general summary of the Lewis structure and the KEKULE structure. Please take note. Whenever you are dealing with the outermost electron, which is the valence electron, you have to use Lewis structure. But as long as you are dealing with straight chains, which is bond, something like this, double bond, triple bond, you have to use what? The KEKULE structure. And 2 electrons that are covalently bonded together, represent a single bond, 4 electrons that are covalently bonded together represent a double bond, and 6 electrons that are covalently bonded together represent the what? The triple bond. If you have any question regarding everything I've explained so far, please feel free to drop that in the comment section and I'll be waiting. But I have a question for you real quick. How many electrons does magnesium have in the valence shell? Magnesium have how many electrons in its valence shell? If you know the answer, please drop that in the comment section. See you in our next episode. But for now, goodbye.